Now we will see the difference of the quality checks of the Agilent 1 color and 2 color data. As we have seen earlier that for the Agilent data we have to do the normalization first and then we will check the quality of the data. And previously we have seen that the raw data is converted into a normalized data and that is saved as a object data 2. So same data 2 object we will use for the checking of the quality of the data. And we have seen that we can check the quality by drawing the or plotting the MA plots, and we can plot one MA plot for one array, but it is easier to plot 6 arrays at a time by using the Lima package, and by using the command plot MA 3 by 2. 3 by 2 means 3 into 2 6, so we can plot 6 images of the 6 arrays at the same time. And this Lima package, by using this command, will draw the image of the 6 arrays, and we can then analyze these arrays by using the command plot MA 3 by 2 DAT2, and then we can convert this plots into the PDF file also, because we can use it outside the R program. So after using that command, we will get the 6 plots, and the plots in the first file show some saturation in the higher end of the scale. You can see saturation. So saturation can be spotted by looking for lines in the lower of higher end of the expression value scale. In the first plot on top left, saturated spots form a very distinct line extending from top left to lower right. So there are often some saturated spots, but their frequency should not be too high. If there are very many saturated spots, then the scanner settings used while scanning the slides could have been wrong. Other quality control images that include the smooth histogram for both channels and all arrays of the normalized data, and that can be obtained by using the command plot densities and then in brackets dat2 data that we have already normalized. So by using this command we can use other forms of quality checks apart from MA plots. So here we will get this type of graph, and this is smooth histogram graph, and for all arrays and for both channels, and it looks all 12 or 14 graphs looks very similar in the pattern. So there are no symmetric biases in the data anymore, and normalization has done a good job in removing them. So this is the quality of the normalization. In order to check the quality of one color Agilent data, we have to use some different tools as compared to the two color Agilent data. But in one color Agilent data, we cannot visualize the data as in case of two color Agilent data. So for one color data, we have to use the other types of tools as compared to the two color data. So in this case we will use the box plot instead of MA plots. So in this case we have to normalize the data that is stored as a dat2, and we will use the command dat.m, and this object needs to be converted into a data frame, and for this purpose we will use the command boxplot, and in the arguments we will use data.frame and then dat.m. So for one color data, instead of MA plot, we will get the box plot of all the 14 chip arrays data. So this is a standard box plot where every single array is represented by one box. So this is one box. The median are all on the same level. We can say median. This is same level. Medians are marked with the horizontal bars. This is horizontal bars within the boxes. All arrays seem to have exactly the same distribution of expression values, and this is the result of quantile normalization, and specifically makes the distribution exactly the same. So after normalization, we have checked that the quality of the data after normalization is perfect.